as ESA's Hera mission completes pre-launch tests for planetary defense. Its target asteroids emerge as intriguing small worlds. This week's special issue of Nature Communications features studies on the asteroid Didymos and its moonlet Dimorphos, based on close-up images from NASA's DART spacecraft and the Italian space agency's LICIACube. On September 26, 2022, NASA's Double Asteroid Redirection Test, DART spacecraft, collided with Dimorphos at a speed of 6.1 km/s. This first test of the kinetic impact method successfully shortened Dimorphos's orbit around Didymos by over half an hour, as observed from Earth and LICIACube. Scientists are analyzing the data to understand the kinetic impact process and asteroid characteristics. The images from DART's DRACO camera and LICIACube provide critical data until ESA's Hera mission arrives at Didymos for further study in late 2026. The amount of information derived from the few minutes of short images returned by DART and LICIACube is extraordinary, says Patrick Michel, Hera's principal investigator and research director at CNRS at the Observatoire de la Côte d'Azur. These images have contributed to over 80 scientific papers published to date. The Nature Communications papers are a collaboration among various European research institutions, including Johns Hopkins University Applied Physics Laboratory, APL, in Maryland, Italy's National Institute for Astrophysics, INAF, and France's Institute of Aeronautics and Space, ICE-SUPAERO. An APL-led paper uses this input to model the ages and origins of the two bodies. The mountain-sized Didymos is estimated to be 12.5 million years old, while Dimorphos is less than 300,000 years old, indicating a recent formation or resurfacing event. Comparing topography and rock distribution suggests that Dimorphos was created from material shed by Didymos. Didymos, the fastest-spinning asteroid humanity has visited, features rocky highlands and a smoother equator where shedding likely occurred. INAF's Maurizio Pajola and co-authors led a paper comparing rocks on both asteroids, concluding that Dimorphos likely consists of Didymos material, consistent with previous findings. Another INAF paper by Alice Lucchetti and colleagues found that thermal fatigue rapidly breaks down rocks on Dimorphos, producing fine dust faster than previously thought, significantly altering the asteroid's surface features. A study led by Jean Bigot and Pauline Lombardo under Naomi Murdoch's supervision at ICE-SUPAERO tracked rock imprints on Didymos to reveal its low bearing capacity, much lower than dry sand or lunar soil. This finding is crucial for understanding surface reactions and landing predictions. ICE-SUPAERO's Colas Robin and Alexia Duchine analyzed Dimorphos's rocks, comparing them with those on other small rubble pile asteroids like Itokawa, Ryugu, and Bennu, showing similarities indicating a common formation and evolution process. The team notes, the longitudinal structure of the rocks around the DART impact site implies they might have formed during the impact process. When Hera arrives at the Didymos system in late 2026, it will release CubeSats for complementary observations, including the first radar survey inside an asteroid. This will enhance the analysis initiated by DART. Patrick Michel comments, Hera will document all the necessary characteristics of the binary system and the outcome of the DART impact. Together, Hera and DART will conduct the first fully documented asteroid deflection test. This is crucial for validating numerical impact models at real asteroid scale, applying them to other scenarios, and evaluating the efficiency of the kinetic impact technique. Hera is currently completing its test campaign at ESA's ESTEC Test Center in the Netherlands and is preparing to be transported to Cape Canaveral in September for an October launch aboard a SpaceX Falcon 9.